Yeah.
Let's say I have a collection of functions written in C,
Mhm.
just called C function.
Uh-huh.
How much of a difference does that active expression really make then? And how difficult is it to really change that without?
So this is actually, when I did this function, this was kind of adapted from something that I had been doing before using .c. So usually it's just as difficult as writing a little wrapper where you do one of these S expression functions, allocate on R, then call the old function you were doing anyway, and just place it into whatever object you just made. I don't have like a quantitative answer for you on how much faster it is, but it can be a lot faster.
Something about passing the information?
I think what it is that R kind of has to generate a wrapper like this if you use a .c call. And so I think that maybe for very large calls, like if you're doing a .c call and it's going to be running forever, maybe that overhead is kind of balanced out. But this can be, when I had done this before without using the .call and I was using the .c, I was not seeing results like this. I mean, I actually hadn't even been using it much because the performance difference just wasn't there. So it can make a big difference, but I don't really have an answer for you on what particular situations it does. Any other questions? Yeah.
Do you know how calling C directly from R compares to using RCPP?
RCPP, I've seen mostly examples where they do like inline defining of C functions. I think it'll be similar. I really just prefer to be able to do my own compiling and see exactly what's going in there. I think RCPP, you can pass it flags. Really important flags to use as this mRch equals native is going to make a huge difference. If you use ICCC, this is kind of the same as a flag called xhost. And as long as you use RCPP in that way and you pass it the right flags, I think it should be similar. But I haven't really used RCPP much just because since I was coming from some C programming, this was just the most straightforward way to get to where I wanted to be. Yeah.
So you're telling me I shouldn't have unprotected sex?
Exactly. I really think you should have done that, like come up here and stood for the camera so this made it on the final video. Okay.
Second question.
Yeah.
What's a good, so I'm just going to pick up the dueling torch just to be a adversarial person here.
Sure.
But like basically this is, like calling C from R is essentially, it sounds like C's doing all the heavy lifting, and which it should because it's got the speed and stuff like that.
Mm-hmm.
But other than graphics, like what are you using R for? Like what?
Oh, I mean, so I'm really using R for prototyping. Like I don't do this kind of C code, or I mean, this is code that I've used now, over and over again. But I mean, I'm doing all my prototyping in R. If I do an MC loop, I'm just writing the loop in R with all the matrix multiply, and that's why it's it's only when I'm doing final runs that I then put it into C. And yeah, it's calling C, but R is written in C and Fortran. And so everything you do in R is already doing everything in C and Fortran to begin with. This is R just provides this nice method of extending the program itself. And so it's really not using even though it's using a different language, it's really just adding on in the same style that R is written in to begin with.
Yeah.
And so you're right, in my final runs, it'll look like setting a bunch of things up, defining matrix sizes, generating some data, and then I'll have just do my MC, and it'll be one line, and it'll call C code, and then at the end it'll be produce graphics. Gotcha. And so my final programs might look like that, but the steps to get there, the prototyping is just all R code. And so, I really think I think kind of a good toolkit to have is an interpretive language, an interactive language, and a low-level language. You know, if you're not, some people just love, you know, like just learning languages, including, you know, spoken languages, programming languages. If you're someone like that and you know 20 of them, you know, that's great. But I think kind of a bare minimum is interactive language and a low-level language. And so, you know, Julia is fine if you can do. I just am not a language person, so once I know R, I don't need another interactive language. And Julia, you know, advertises that it's great because you can interface with C also. And so most of those style of languages have to provide a low-level interface. And we'll talk about how easy that is. And I just like that R's low-level interface is really in the same style as how the program's written in the first place.
One more question. Well, how do you, so I imagine you write it up in R, you prototype it, and then check to make sure everything's converging and all that kind of stuff.
Yeah.
What do you specifically use to profile your code? Because I've used like R profile, which is because you obviously want to pick off the points in your code that are the most egregious as far as
So for my MCMC, eventually all of it will be done in C, and so I don't do much profiling in R for that loop or so. And in C, naive implementations are very fast, and so I've never really had a profiling problem once I get in there. So I don't do much profiling to begin with. Like when I just chose that I wanted faster random number generation, that's because I just know that that's a big time part of it. So I don't do much formal profiling, which is not standard.
Yeah, my concern is like you write a whole program in R, and then the task of rewriting it in C is a big one, and you're going to get huge speed increases accordingly. But I've also heard, you know, write it in R, pick out the biggest offenders as far as computation time goes, code those up in C, and at least you've got something that's like, you make, you know, you shave off a big chunk of time, but it's not the same task as like porting it.
So the big limitation of that is say you have part of your code that's 90% of your code, and you're going to speed up that portion. So you're saying, I'm taking a big chunk, 90% of my time in R is spent doing this. And the limit on how much faster your whole program can get is 10 times as fast, because you have that 10% that you're not optimizing.
Yeah.
And so even if you're taking a huge chunk, you profile your code, 90% of your time is there, I'm never going to get more than a 10 times speed up. If I recode whole sections, like whole loops in MCMC, I can get 1,000 times faster. You know, it's, so really I would say like loops and things like that need to be, you ideally take the whole loop and put it into C instead of taking out the individual components that take a long time. And if you get comfortable, BLAST libraries, you know, these functions, once you get used to writing them, you kind of view them, you know, instead of A times B, it's just a little bit, you just have to pass it dimensions of matrices. And so even though it looks very complicated, translating simple code in terms of like, you know, generating random variables, matrix multiplication, you can end up becoming relatively fast in C or something like that, because you're not coding from scratch. You're taking advantage of these libraries that are available to you.
What's a good resource for libraries like OpenBlast and
so
I'm sure they've got documentation, but everyone says look at the documentation, it's like 400 pages of stuff, and I'm not going to read through that. You know?
So in the documentation, I mean, literally that's kind of how I had to learn it, is the documentation will go through each function, tell you the format, what arguments it takes, and literally will define each argument and say this means this. A needs to be an n by k matrix if you give it n and k up here, and it tells you which things need to be pointers, and that's literally just how you have to do it. When you do things in C, when you do use BLAST libraries, you really should take advantage of that they have symmetric matrix multiplication and triangular matrix multiplication, because that's way fast. R can only do general matrix. I'm not sure about Julia, if you can tell it whether a matrix is symmetric or triangular, but that can also be a huge speed up, because I don't need to be accessing every element of this matrix to do things like that. But you know, it's kind of hard to find, you know, it's kind of hard to find functions that look like this if you're looking for code. This kind of stuff was pieced together by me just scouring the internet, but there's not a lot out there that's really, I don't know of a really good resource.
Yeah, see, and that's what scares me about all this, because I see that, and I pee my pants a little bit, because it's like, well, there's, I'm not going to take, there's so much there, and I know the speed is worth it, but the cost of piecing all these different, like, the CUDA stuff and the C stuff, and everybody in one big happy family and working together with the hardware is great, but it's this big mountain of
yeah. I mean, I would.
That I just like. There doesn't even seem like an accessible way up the mountain. There's no trail that
Yeah.
I can find, and I left my rock climbing gear at home, and I'm a crappy rock climber to begin with. So I don't know. It's something I want to know, but I get discouraged every single time I look at it, because it's just like.
Really, I think what helped me was once I had some simple it took me a long time, but once you have some simple programs that you really have running and you can start using and then maybe altering them yourself and looking at output. So once you have some example programs out there that are useful for things that you need, then the learning comes much more quickly. But so it's really hard to find, if you look up C programming, there's things where people need to, parse strings and kind of want to write interactive programs, and that's not really what I want to do. I just want to crunch numbers and spit something out at the end. And so it is hard to find examples, but so I wanted to give, I chose these two example functions because, you could use them depending on your hardware, like this GSL, you can install and compile this stuff, tomorrow and use it right away. And it's a working example of something that statisticians actually care about. And these examples are hard to find online.
Yeah, no, I can't wait to go through your code.
And it's provided with no warranty and no support. I have a 24-hour, 1-800 line for support. But so yeah, it is daunting. But one of the things for simple stuff, like I've used even, to just create covariance matrices. You can starting to write little, just simple for loops where you assign things. Like I make Toeplitz matrices for covariance functions, and I just have a little C loop that just is, 3 lines long, and I can call it from R. And just starting with very, very simple examples is really just how you get there. And you do kind of need to read through documentation. If you want to get comfortable with BLAST, there's really no other way than really knowing what arguments it takes. And their error messages are great. I mean, like in BLAST, if you give it the wrong argument for one of its arguments, it does negative and then tells you which argument's wrong. And so, yeah.
I'm sure I'll see a lot of it.
Yeah. So let me know if anyone has any questions about this stuff, and I'll try to help you out. Because this style coding, I'm sure you could interface this kind of stuff with Julia too. I mean, Julia can interface with C also, and I hope this part's generally useful. The BLAST libraries are fairly simple, and I would say everyone should just do that, get it out of the way, and never think of it again. Just make R that much faster and move on with your life.